The amplifier's job is to take a weak audio signal and boost it to generate a signal that is powerful enough to drive a speaker. This is an accurate description when you consider the amplifier as a whole, but the process inside the amplifier is a little more complex. In reality, the amplifier generates a completely new output signal based on the input signal. You can understand these signals as two separate circuits. The output circuit is generated by the amplifier's power supply, which draws energy from a battery or power outlet. The input circuit is the electrical audio signal recorded on tape or running in from a microphone. Its load is modifying the output circuit. It applies a varying resistance to the output circuit to recreate the voltage fluctuations of the original audio signal. One of the most basic components of an amplifier circuit is the transistor. In an NPN transistor, the P-type semiconductor will be kept in between two N-type semiconductors. From the left, the first N-type semiconductor is called the emitter. The middle P-type semiconductor is called the base, and the end N-type semiconductor is called the collector. The output circuit, which is supposed to drive the speaker, is connected between the collector and the emitter ends. The input circuit will be connected between the emitter and the base terminals. The amplifier's output circuit is connected to the emitter and the collector. The input circuit is connected to the emitter and the base. When no current flows through the input circuit, free electrons from the N-type material fill the available holes in the P-type material. This creates depletion zones, areas where current can't flow easily, at the boundaries between the N-type layers and the P-type layer. When current flows across the input circuit, it causes an extra voltage boost at the base electrode. This gets electrons moving again, shrinking the depletion zones. Electrical resistance drops, and electrons can move from the emitter to the collector again. In this way, the voltage at the base electrode determines the overall resistance of the transistor, and therefore the current in the output signal.